The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont on behalf of HawaiiTracker.com, bringing you guys another volcano update. This time it's Mauna Loa on Friday, our Friday Mauna Loa update, April 23rd, 2021. You guys are seeing the last 24 hours webcam looping on Mauna Loa here on the USGS site. There's still a little bit of snow here in the background. You can see it back in this area right in here. Some snow there in the background. But that's what it looks like on Mauna Loa today. There's not been a whole lot of change up there. There's been some rumblings underground. Another small seismic swarm has been reported by the USGS in their weekly update. Not a whole lot of details there, so we're gonna have to dive into a little bit more detail to see how this fits into the pattern of what's going on recently. So we'll be taking some questions at the end of our, essentially as an earthquake summary today. We'll be looking at maps and plots and graphs. At the end of that, we'll discuss some viewer questions. Dan will collect some questions and answer what he can on that chat and make sure our streams are running well. So let us know if you have any issues. Otherwise, we'll get to it and jump into Mauna Loa here. Start off by looking today at the tilt and GPS signal. This is all, of course, using USGS, Hawaiian Volcano Observatory information, data from their website here. Over the past week, the tilt here, this is a ground tilt, is just showing small variations. These are essentially what we'd consider the background, whether it's tides or solar effects or what have you. You're having some daily variation up and down. And what's really important is that there may be a slight trend. Whoop, that's not a line. There might be a slight trend going up this way. Slight trend going up this way, but overall it's below 1 microradian up and half microradian down. So 1.5 microradians, very small change. If we're looking at past month here, we see it is a noticeable little rise, but it's not the same as what we were seeing earlier over here, right? So you might be having some adjustment of magma underground still. This one over here related to, we believe, movement of magma. Perhaps into some of the deeper rift zone areas from that shallower summit area that led to what appears to be this deflationary signal right here. Blue line right here. And so then recovering and then maybe coming back down very slightly. And nothing as dramatic as this, of course. But still an adjustment is what the tilt's telling us without looking at anything else yet. If we come into the GPS here, this is the distance across the caldera north to south. So in meters here on the left, and this is a 1-year plot left to right. So let's zoom in here to the right end of this graph, over here. And over the last week, we've continued essentially a slow extension here, spreading north and south. The distance is rising north, on the graph here. So not as much as it has been some other points. It's been fairly steep in the past, even recently, but we haven't seen that. It's maybe something more akin to what we're seeing in here, seeing it again over here after we've gone through that. What was essentially a 2 to 3 week contraction period, at least on a summit of the volcano, maybe not across the entire volcano. It's a big place, so it's hard to see what's happening here at the very end. It may be doing some wiggling and adjusting still, and it may not come straight up. It might do some wiggling based on what we're trying to make out here. It's always hard to tell what's going on the right end of the graph here, and it's a little tricky and a little noisy. So we'll have to wait and see, but it appears at least that we can tell that we are still on that extensional path extension trend. That's a GPS. That's basically what we have. Just to show you guys this 5-year plot. This most recent contraction we had is the biggest one we've had within the whole past 5 years, and the one we had previous to that was the second biggest in the last 5 years. So we're having more change certainly here in the last few months than we've had any time in the past 5 years, at least more dramatic, right? There's been a lot of change happening, but not of this variety like this summit. So interesting to note. And now we'll turn to the earthquakes and start off with what we usually look at, the traditional USGS earthquakes page. And if we look on here, we'll look at this is the last show our key here. Yellow is the last week, orange is the last day, red's the last hour. I'm going to zoom in here. We're not seeing a whole lot of events. It's not an obvious earthquake swarm. You do see that there are some events in here. 0.9, 0.9, 0.9. Come in closer, see them a little bit better. But it doesn't look really like that big of an event just on this USGS scale here. So let's look at this a different way, and let's see what they're talking about here. So first, let's go to the text update and see where this information is coming from. This is the most recent update from the USGS, issued yesterday, Thursday, April 22nd. And Mauna Loa is not erupting. Deformation and seismicity rates are slightly elevated still and above long-term background levels, but I think of it as we have a new background now, a new elevated background. So we still have that going on, but it is higher than before. Other data streams show no significant change in deformation rates or patterns, and nothing that would indicate increased volcanic hazard at this time. So the new information here is this earthquake swarm occurred southwest of Mauna Loa summit on April 16th and 17th. During the past week, HVO seismometers recorded approximately 175 small magnitude. They mean 2.5 usually and lower magnitude. Most below the summit and upper elevation flanks. So when we read these updates, this location is one of the important things, is where are these earthquakes happening. So they're saying essentially most, if not all of them, below the summit and upper elevation flanks, rather than being elsewhere on the lower flanks, which is a pattern we're shifting between here. Nearly all less than 3 and all in that same typical range below 5 miles of the ground level. and that's where that swarm comes from. They don't tell us much more than that. So we are going to go to the Iris earthquake browser here, and I'm going to show you guys. It's probably hard to see here. Yeah, I can zoom it in some more. Let me push the play button here, but so we can actually animate through the Iris earthquake browser here these earthquakes on Mauna Loa. Maybe. Earthquake. No, they're not.
Not working.
Does not seem to be compatible here. All right,
Well, you tried.
We'll go to the USGS view. Do that a different way. So the USGS view here for the last week. This is showing mostly what happened during those earthquakes. And so that cluster is right in here. There was one larger event, which was this one. It was a 3.2 in that same range. And lots of small ones following after that. So the majority of them are small that kind of follow. And that's most of the action here. And previous to that, we have these other earthquakes up here in Upper Southwest Rift. So we'll scroll down here. And you can see in map view the cluster there, but let's keep going. Let's look at the past week. Really, that cluster spiked about a week ago or so and has been coming down. If we look at the automatic time on the bottom versus depth on that plot here, we can see that about a week ago we had that 3.2 right here, there, followed by a trail of smaller earthquakes. That same, so that's that small swarm right there. That's that one most recent one we had just about a week ago or so. So in and of itself, it's, you know, as we've said, none of these events by themselves is super significant as far as changing the prognosis of the volcano. But when you start adding them all together, that's when it gets more interesting. So let's go to the. First of all, I'm gonna switch back here. We're gonna look at a quick couple diagrams from this paper, professional paper. Which one is it here? It's 1350 in chapter 19, the Mauna Loa summary of the 75 and 84 activity here by John Lockwood and other HVO scientists here. So they, at that point in time, were having very similar earthquake patterns as we have now. And this plot here, or this cluster here northwest of the summit caldera, and that similar cluster here in upper southwest rift zone. So they're drawing a cross section going across this direction, cutting through there, and they summarize a bunch of stuff. And so I'm going to just skip to the chase for you guys here and show you guys their interpretation of what they think is the magma configuration as far as a storage body. So zone A is what they're classifying as essentially that smaller magma chamber. It may not be like this. It may be a smaller zone within a larger dike, as we've saw in some of the more recent diagrams, right? We have possible location of inflation right in here. But essentially what you have is a zone of no seismicity. So they're drawing squares as a certain depth here. These are all earthquakes. And these little cross signs, these little plus signs, are also all earthquakes. So those are all happening in brittle rock above the magma chamber right in here and off to the northwest side over here. You don't get quite as many over here on the east side. They are there, but they're not quite as concentrated. They're distributed across the whole southeast flank, it turns out. Because when we look at the volcano of Mauna Loa, it's got quite a light to its northwest, and it really can't push and move in that direction at all. So any pressure of the magma chamber it's pushing towards Hualalai and Kona, it seems to pinch and catch in this zone right in here. So that's that zone that we're seeing flare off over here and here. So essentially it relates directly to the magma chamber pushing on it from the side, right? That's kind of, and maybe pushing more to the side, perhaps from this deeper zone over there, or the lower part. And when it gets to the shallower parts of the magma area, then it's pushing more up. And that's when you see these other earthquakes on the summit, kind of above the magma chamber. I thought this might be a good one to orient ourselves as far as what these earthquakes actually are, right? So we're not actually looking at the magma chamber directly. we're looking at the area right next to it and essentially interpreting how much pressure it's putting on there by these different earthquake swarms. Not only here, but also up here and also up here. And that's the pattern we're trying to look at, is essentially, where is it pushing? Is it pushing this way? Is it pushing it this way? Or is it pushing it that way? Because we know that it's coming in and it's filling up. It's just a matter of where is it going and what's it pushing, and which way it pushes may then encourage it to fill areas underground in a volcano there. And then that's the cycle that we've been going through. So, all right, let's go back to the USGS past month here. So for the past month, you can see a summary of what essentially is the last 3 earthquake swarms. We've had 3 weeks in a row of earthquake clustering in this same area. It's a little bit more up here, but more so in this lower area where that bigger earthquake and a lot of these small ones are all there. And of course, a lot of other stuff around there as well. So that's the map. Let's scroll down here and let's go down to the past month plot here. And this is perhaps the best, most convincing one we can show today. You can see 3 clear spikes here. There is one swarm, second one, third one. Right, and so the key thing here is that we're not having a swarm that's ongoing and staying at high rates the entire time. So we're spiking up, and we're going back down to our background. Our background now is higher than before. It's an elevated background, but we're still going back to background. And then we're going up and back to background, and then coming up and back to background. So that's the pattern we're seeing here. It's pretty beautiful to see that in the data like that. And noteworthy that if you were looking at any scale other than the past month, then you don't see this pattern right here. So it just happens to be the right day to look at the past month earthquakes per day plot here. This one reaching 120. This one reached 70 in one day. This one reached 60 in one day, right? But we're kind of counting the entire tail end of it as well as part of the swarm. That whole thing. So if we look at the depth versus time once again here on the bottom, we can see corresponding to the same periods of time above it, there's that top swarm right in here, earliest one. And here it is coming in. And this is a shallow earthquake as well, but mostly we're seeing in this swarm. Second one in here. Third one was actually smallest right in here, although you may consider it to be possibly ongoing here. Some other stuff happening there. Right, so yeah, that's actually it. If we look below a spike here, actually this one, that's that swarm right in there. Looks like there was a smaller one that preceded it right in there. Maybe didn't get quite the attention, but or maybe it's all lumped together as one bit. In any case, three different peaks there, and importantly, going back to background. We'll be more concerned when this doesn't go back to background. Of course, a lot of adjustments are happening, and we'll talk about what that means here shortly too. Let me try this one more time. That maybe now we can see the past month. I believe that's playing, yeah. All right, so here's the beginning, about a month ago. First wave comes in, there it is, here. And a little gap, there's some background activity. There's our upper southwest rift zone. Here's our second pulse coming through. And finally our third pulse, right in there at the end. A few more upper southwest rift earthquakes as well. That's the last month pattern right in there. Glad that finally played. See all three there together. I'll zoom it out a little bit too. So this is that zone when we're looking at that cross section. The cross section was going across this way with a magma chamber somewhere under here, that long dike reservoir as well in there, and it pushing towards Hualalai, towards the southeast here, right? So if I move this direction, you can see Hualalai is right up here, and this is Hualalai volcano. And really, you can't push this flank in that direction. There's a whole backstop right here, a big doorstop. You can't slide out of the way. Whereas if we go to the Kilauea side, and Kilauea moves, so therefore Mauna Loa can also move in that direction. Okay, that's the past the past month here, but I also, let's see, maybe close that one. All right, so this is showing the past 2 months now. So we have that little cluster, I'm zoomed out a little bit, happening right in here, northwest of the summit. But you also see early on, there's quite a lot of shallow activity, all essentially above sea level in this summit and upper southwest rift zone right in here. We get that upper Kaʻōiki swarm happening right in here. This is the whole Kaʻōiki area right in here. And that's areas all activating. We see a couple of those big south flank earthquakes, 4.2, 3.9 happening down in here near Pāhala. And so those are the areas that we're dealing with. Let me zoom in here in a summit a little more. So here come our swarms here in the northwest. And in the meantime, you see that there's nothing adding to the summit. So essentially we had early on here at the beginning of the sequence, starting the sequence, we have pressure above the magma chamber right here. Then we shift to having flank earthquakes. I'm zoomed in so you can't see them. But once the flank earthquakes initiate, then we start seeing pressure pushing to the sides and less so up. And that's kind of what we're seeing, a change from pushing up to pushing to the side. So let me zoom it back out now. Out. There it is. This is a lot of, a lot of little dots just popping up around here. But to show you guys here for the last year, the last 2 months is this section right here on the right. So from February till now is this era of elevated earthquakes per week, where we've been mostly above 100 earthquakes a week for most of the time, a couple exceptions, which is different than that period before then, right? You see, before then, our background was actually quite a bit lower. So this is what we mean by the background levels and then an elevated background level here. That's the difference we're seeing here. Certainly adjusting quite a lot. And if we so let's see. We're going to go to the Mauna Loa monitoring map now on the USGS page as well. Too many of these earthquake maps open at the same time. They each have their memory issues. So what I've done here in this Mauna Loa map, and this is, so we've checked out the main USGS earthquakes. We've looked at the IRIS earthquake browser. Now I'm on a USGS HVO homepage looking at the Mauna Loa monitoring map. What I've done here is I've gone to the settings over here, and there's a setting right up here, how you color the earthquakes. And normally you see this by time, right? But I've actually switched it to depth here, because we've been looking at time already. The other USGS map offers this one by looking at by depth. You can see across the whole island here. Just give me some more screen space. The pattern of earthquakes. So we have all the deep stuff happening around Pāhala. And these orange ones, that's the south flank of Mauna Loa, these orange ones right in here. And the maroon ones, that's the summit ones above sea level, that's right in here. And those shallow ones, they're over here. You get a couple of these shallow and kind of flank earthquakes right in this Kona side as well, right there, and then a few more, obviously, in here. But this gives you a better idea when we're talking about the depths of where these earthquakes are happening, where they might be at one visual glance. So we're going to take these colors and we're going to generate some of these cross sections here. So I've done this previously to try to reduce the strain on the computer. And so this first cross section going just across the summit region right in here. Right? And this unfortunately, this USGS main page only supports the last month of data at most, so you can't go back farther than that. Each of these maps also has their own limitations. So that's the one on this one, but strength is we can draw these cross sections. So for the past month, on that line, you can see here, across the summit, are 3 earthquake swarms. It's similar to the automatic plot, but it's a little bit more detailed. So we see here's our first swarm, and the maroon one's adjustments in the caldera above sea level. Second one comes in here. Our third one is right in here. This last one is interesting. It didn't last quite as long, but it did go from deeper to shallower. Not as much in the shallow end, but it's starting to show a little bit more range, which is interesting. And as these patterns change, the one thing we're looking for is, do we see things moving towards the surface? And not exactly, but showing some indication that you're able to propagate stress, like the forces, like a domino effect, right? At least to getting up to these upper regions. Not as much as down here, but that's starting to happen a little bit there. One more cross section here, and this one I'll try to do is take all of Mauna Loa. So here's that legend once again. Maroon for above sea level, and then all other colors here, miles. Try to take most of Mauna Loa. We've got a little bit of this Pāhala zone right here, maybe the Mauna Loa side of it. Try to stay out of Kilauea, apart from maybe where we adjust next to it, but include most of Mauna Loa summit and most of this flank stuff that occurs as well. So for the last month, what does that look like? So here you see it. Start off from the bottom. We have these light blue colors. That's the Pāhala mantle plume generation zone of magma, right? That's that deep source of magma that goes to Mauna Loa, Kilauea, and Loihi volcanoes. We have these purple ones. That's the crust under Mauna Loa, adjusting to the weight of it. So everything is shifting on top. Eventually, the bottom of it's going to settle as well, right? It's almost like a giant waterbed. So we keep wiggling on top. Eventually, the bottom's going to wiggle as well too. So, but minor adjustments there. A big gap. Not a lot happening here, and this is the actual stack of the volcanic pile right in here. So the flank earthquakes are the orange ones. You can see that they're happening, but not as much. You certainly don't see it as continuous. You don't see the same pattern as you see in these shallower ones, right? The red ones definitely are showing, right? What we're seeing is this pressure on that northwest side at that particular depth only. And one thing we're looking for building up to an eruption is you expect to see these intermediate ones also pick up quite a bit as well. So we're seeing one of the parameters, but we're not seeing everything we need. We're not seeing as much activity here in intermediate range earthquakes. And so that's something to look for as well coming up. So we'll wrap it up here pretty quick on the earthquakes and switch to questions. But first I want to show you guys here, this is now a larger frame. So, and we can explore this a little bit more too, but I've put it back to September 2018. So just as the Kilauea eruption was ending, right? Which was a period when Mauna Loa began to adjust, coming out of its relatively quiet time while Kilauea was erupting. So let's play it here. It goes a little faster because I'm spanning so much time. So Kilauea is over here, and this reminds me that, of course, Mauna Loa doesn't exist in a vacuum. Kilauea did erupt, is erupting now, right, in 2020. So it is also, there's some dynamic happening here between Mauna Loa pushing, Kilauea pushing as well, so that's not to be ignored. But here before Kilauea's eruption, you see these little flare-offs. That was our giveaway that Kilauea was building pressure. It wasn't just the summit anymore, it was actually putting out these wings. And that's when we were getting concerned about the pressure in Kilauea. So we're not seeing anything like that in Mauna Loa yet. We're see early on a lot of summit activity. Also that northwest flank. You can see a little bit better with this longer period of time, this whole area of Kaʻōiki is also adjusting, right? So here it's spread out over that whole area to the east, and to the west, it's all clustered in one zone. There's a second patch here, there's a patch down in here, which is also adjusting. You can see some flaring happening in there as well. Zoom it out a little bit. And interesting, during this time, we also have Loihi coming in offshore. Happened in 2020. There was a little seismic swarm at Loihi as well. Right, no eruption, it just came in and quieted back down. You can see Kilauea south flank still has been moving quite a bit since then, and of course that whole eruption access in here, right? So, but really, hopefully you guys can see more so of the south flank pattern right in here. How much summit's going on, right? We're seeing that cloud at the summit. We don't see wings into any of the rift zones, anything like that. Instead, we see pressure on the side here and here. Right? That's because we have this long dike body that's this orientation that's filling in. So it's pushing above, it's pushing to the left, it's pushing to the right, and it's just filling in. And as it pushes to the right, this thing's giving and moving. And this one is not moving as much, which is why you see these earthquake swarms. On this side, it moves. We have this big earthquakes, the 3.9, the 4.3 over here. There was on March 10th, there was a 4.2 somewhere in here. Mauna Loa south flank that went that way. The contraction we've seen at the summit, Mauna Loa, over the last month or so now, is the largest in the last 5 years, as we pointed out earlier. So that's clearly we're adjusting a lot. We're adjusting contraction at the top. We're adjusting lots of earthquakes all around, and that's this whole process that we've described in the past here, right? Where we're not seeing a full-on eruptive cycle, but we're seeing a smaller version, incremental version of that, right? Where magma comes in, right? It presses on the flanks fail through an earthquake. That leads to magma filling the area, more earthquakes at the summit, and then possibly pushing to the sides, right? And over and over and over again, right? The magma moving perhaps into other areas of the rift zone as the volcano expands and as flanks move out of the way, essentially creates space for the magma to fill underground without actually erupting to the surface. So that is the summary of what's been happening in Mauna Loa over the last week, over the last month essentially now, and mostly to do with earthquakes here and different ways to look at the earthquakes through the SGS in a couple ways, through IRIS, and a little bit with the GPS, but that's really the information we have, right? There's not a lot else going on there. It's interesting to note that there's no heat, there's no gas, the tilt's not really showing anything that different. I was interested when I was reading that paper by Lockwood et al., how between the 75 and 84 eruptions, there were fumaroles in the summit that were somewhere around 300 degrees Celsius that were active that entire time. Right? That was 9 years of heat coming in there when it was building towards eruption. 75 was a little bit different, of course. And that's why I personally think that might be a better analog right now, that initial phase of eruption, rather than that later flank stage, right? So, but, just to say the volcano can sustain fumaroles with 300-degree temperatures for years and years and years, and it's not doing even that. And so we're still coming and adjusting. Of course, this paper in 2005 was really focused on the big earthquakes that can occur on the flanks, and what big earthquakes can then lead to big adjustments, and that's when you get an actual eruption. Right? So earthquakes on a Kaʻōiki fault in 1983 preceded 84 eruption, earthquake in 74, I believe, preceded the 75 eruption, and on and on and on. I think it's not every single time, but many times, I believe 9 recorded hearings of that process there. So what we're looking for still is, if we're seeing this pattern of it's adjusting a little bit, adjusting a little bit, adjusting a little bit, do we get to the point where it adjusts a lot? We get a big earthquake. That might be the next thing that might be in line for us, is if this pattern of we're seeing a flank is pressurized, where it is adjusting through earthquakes more often than before. So at what point do we pick it up a gear and get the big earthquake somewhere on the flank? That's seems like what might come next at this point. And from there, then it's a whole other paradigm. And of course, there's a lot of slowdown, and things can happen, and things can move around, and nothing can erupt, and all that will still be the case. But we still haven't even got that big earthquake as that first indicator. We haven't even got that yet. So that's where we are now. All right, Dane.
All right. Well, we got a few questions here, but before we dive into that, I do want to, say we are brought to you by Hawaii Tracker, and you could help us out by sharing this video, liking, subscribing, all that stuff. It really does help this channel sustain itself, help us grow, help us get a little more out there. We don't have advertising budget, so really, the viewers help us out tremendously. So we also do take donations on hawaiitracker.com/support. And I do want to thank a few people there: James P., Mel S., and Tony B. Really appreciate it, you guys. And with that, we have several questions to do to get through. There's some good ones in here too. So let's start with this one. Let's keep focused on Mauna Loa first. Are these the earthquakes that we're looking at? Denise asks, is there any long period earthquakes being mixed in to what we're seeing on the USGS and the HVO earthquake maps, or is that something not indicated?
Yeah, I haven't seen any of these long period tagged earthquakes on the USGS or any of the other sites in a long time. So I don't believe they're being indicated here, right? These are all the brittle earthquakes that we're seeing. So essentially the rock adjusting the brittle rock around the magma. Right? So yeah, it's a good point, Denise, that there certainly can be long period earthquakes indicating magma movement, and that's something that we're not did not bring up today at all. Yeah, something else we can look for sure.
Dr. Jagger asks, was Dick Hirschberger, who anybody that doesn't know, he does the cameo or the cosplaying at as Dr. Jagger at the old HVO Observatory. It's really good stuff if you haven't seen it before.
That would be
he asks
hysterical reenactment for the older viewers.
He asks, how does the swarms compare to the older Mauna Loa eruptions? Just in general, is this?
So there were swarms before other eruptions of Mauna Loa as well, and a lot of them in the same regions, right? And so it's a little bit muddy exactly how you relate what happened back then to what's happening now, because we do see the similar patterns on the surface of the earthquakes. We do see similar kind of swarms. One of the tricky things is filtering ourselves, because we see these earthquakes that are all less than magnitude 1.6 show up on a map, and it's hard to not see them and to, it's hard to unsee them. Whereas in some of the earlier data sets, we didn't have that as much fine data, right? So when the magnitude earthquakes 1.6 and higher were ramping up more, it was a little bit more obvious that was your indicator. So we may see more detail and see more of these swarms that we may not have related exactly the same way before. But yeah, it's really interesting. And there's also the dynamic of the whole south flank and Kilauea and everything else going into it, right? Because in 75, if this was 1975, we would have had only 1 year of buildup of earthquakes and seismicity, and we would have been erupting already. And it's clearly not what's happening here in 2021. It's not what's been happening for the last 40 years, in fact. And it was thought that after the 75 eruption, that 84, the flank eruption might follow within 2 years, as was a pattern, right? Of course, Kilauea was becoming very active in that same time, including that big 1975 South Flank earthquake that was initially a 7.2 and classified as 7.5, and I've even seen 7.7 in places. That same one that preceded the one we had in 2018. So the South Flank of Kilauea was moving, and that maybe threw a gear in a wrench, a wrench in a gears, a wrench in a gears there, and delayed that pattern. And maybe that's why it didn't come within 2 years that particular time. So it just goes to show how there are so many variables and they all affecting each other, that all we can say now is that somehow we're having the same elevated seismicity and swarms, although not to the same elevated level. We're not our background level isn't as high, but we're starting to see that same pattern coming in here, to the point where I would not be surprised to see this larger flank earthquake happen at some point in the fairly near future. Right now, I'm kind of going out on a limb there. We'll see. We have to wait and see, and maybe it'll just ramp back down and nothing will happen, or Kilauea will adjust, and then that'll allow Mauna Loa to do something different as well. And we'll just have to wait and see, of course. Yeah, mahalo for the question, Dick.
So
we'll have to watch and see.
Right. So Brian here has a question. Talking about deep earthquakes, you were just talking about the different earthquakes on Mauna Loa that were going into an eruption. But has there been? Do you know of any deep earthquakes that have kind of tipped off the volcano? Something that was that stands out as creating a cause-effect relationship or even a correlation?
One doesn't come to mind, but I am not nearly as versed on
Right.
all the little details of Mauna Loa.
It always kind of depends again on what is your deep, right? That's the question I come back to. What is deep for you? Because outside of Pāhala, like the 2006, what is it, Kioho Bay? I can't remember the name.
Pāhala Bay.
Earthquake, Kioho
Mhm.
Bay earthquake. Yeah, one. That one was relatively deep if you don't compare it to Pāhala.
Right.
It's all that. What is deep?
Yeah, I mean there are some ones that are
That comes.
deeper than Pāhala here that are on the plots, right? But that review paper by HVO on that professional volume has a plot. Maybe I can find it here. It has a plot of earthquakes that are shallow, intermediate, and deep. And you see the intermediate and shallow ones ramp up before eruptions, but the deep ones don't really seem to. They seem to be almost independent. They just keep trucking along, doing their own thing,
Right.
unaffected, as if nothing else was happening. So I'll just maybe just leave it at that and say that the pattern isn't of that. It's more the intermediate and shallow ones being important.
So we have one more question about deep earthquakes before we get off of it. Jennifer from Facebook asks, during the last month, there's been a number of very deep earthquakes just offshore of the coast in unusual places. Most of them 25 or 26 miles deep. They just kind of going around the island. And what
Yeah,
do you have an explanation for those?
and some underneath it too. That's what these purple ones are right in here. Right, so she's exactly right. These are the ones that happen to be in that box I drew. There's more than just these, but right down there at 25 to 27 miles down, and the ones right. So
Right.
right. So this is a Pāhala zone right in here. So this is deeper than Pāhala zone. Right? So it's essentially that the waterbed under the island, surrounding the whole island, that's adjusting there. So I might have to go back to my early earthquake map. This one. Zoom it out, right? And so there are these other ones that are around there and there and there. That are these adjustment earthquakes essentially. I like to call them settling earthquakes, but they're essentially this big weight of the volcanoes is blowing down the crust underneath here, and as that whole crust moves away and adjusts to the weight, then different parts creak essentially, right? And it might seem like unusual places when we're looking at the frequency. So it's more about the matter of the frequency. So they happen at a fairly low rate, but they happen all over everywhere, all the way out here. And how can I show that for you guys? Maybe if let's try this one. I can zoom it out. So this down here is Loihi over here. But all these other ones you see offshore, all this other stuff is all the settling background. So when you look at just one of them, it's just like, oh, there's just one here and just one there. But really, if you widen your window to several years, then you can see more of what the background pattern is and how it is more, I hate to say regular, but it's more evenly distributed across the background around the island. And that's the best I can show there without having some other document ready here. But if you do find synthesis maps, that are big enough to show the whole island at this scale, you do see the background levels shown in the island. And not nearly as heavy as all the mass under Mauna Loa and here or here, but it is there. You see Mauna Kea also has its own background right in there. A little bit more than the offshore areas, but still has, so when we see under Mauna Kea, different frequency, different rate, but still a normal thing to happen under there. Just, it's different rates for different processes. Yep. Right? So the fastest process and the fastest rates are the magma moving in. and then, maybe more localized settling, and then the wider, broader scaled settling.
All right. Well, thank you, Jennifer, for that one. Dorothy asks, are these earthquakes on Mauna Loa from lava moving under the earth, or from new land formation, or movement of the hotspot, or the flanks moving?
It's the magma coming in. The magma
It's
coming
the magma.
in, and where the magma is moving is not where the earthquakes are. The earthquakes are happening to the side, above it, and to both sides there. So if you look at this last 2 years, it's really much more clear, this whole southeast flank of Mauna Loa right here, how much that, how much part of it that is in there, yeah. And I haven't pointed out here, but actually in this particular animation, I've filtered out the deep earthquakes in Pāhala. They're not actually there. So if you're wondering why they're missing, it's because these are just the stuff that's above there,
Right.
shallower depths. So yeah, this Iris earthquake browser is great. You can do all kinds of fun stuff there.
Okay, Miss Stitcher asks, what age / viscosity of the magma would you anticipate erupting first if Mauna Loa were to erupt again? Would it have a signature from the 1984, or is it possible to bring up batches from previous eruptions before that even?
Yeah, I think it's similar to Kilauea, where there might be other pockets in there, right? And it depends, especially close to the surface, where it might break open. But all this is happening because of some massive adjustment underground. And we know that there was a big batch of magma that came in from 2002 to 2007 that never erupted, but it makes up a huge volume of magma underground. And so that's got its own signature too. It's probably different than 84, but somewhat related. So I would imagine you might see some of that. Mystery signature number 1, and you might see a mystery signature number 2 from some more recent batch that comes up as well in the long term. But you probably would have to clear out 84 stuff, right? I do believe that 84 stuff, for the most part, cleared out to 75 stuff because it went up through very similar pathways. Yeah, and in fact, 84 was kind of left over 75 to start. It's kind of all related.
Right. Similar for Kilauea. Oscar here asks, so if Mauna Loa erupted as in the past, what directions could we start looking for the lava to flow? What are the most common flow areas on Mauna Loa?
Okay, let's see. Maybe what I'll do is I will show a map. Let's show a map. So this is a map, USGS map of Mauna Loa's activity over the last 200 years. It's not. So you have labeled on here and drawn in brighter colors the lava flows in the last 200 years or so. And so that most of the time, to answer the question directly, the eruptions begin at the summit, and half the time they just that's all that happens is a summit eruption, and that's the end of that. And the other half of the time, you can have a summit flank sequence where you can have a summit eruption that then proceeds to either the northeast rift zone or the southwest rift zone. And from there, they can send lava flows down to the north and south from both directions there and there. So that's generally okay because this is all bare land up in here, uninhabited. It's no road up there. There's some trails and there's a lot of there's property and stuff, but it's not going to affect people very much up in that area. We worry about it more if it comes in, for example, 1950 into this upper southwest rift zone here, and then starts spilling out where it goes all the way down to the coast here in the steepest area of the southwest, right, where you can have high flow volumes coming out of here. That's one of the areas that we worry about more so. And one thing that happens is that there is kind of a pattern of rift eruptions flipping from northeast once, and the next time southwest, and the next time northeast, and the next time southwest. So the last eruption was 84, was in northeast. So based on the modeling of how the magma pressure was underground after that, you would expect that you have to do something over here in the southwest. Now that might have happened in 2002 to 2007 in that deep rift part, but we still won't know until whatever eruption happens next in Mauna Loa. But likely it starts at the summit and then ends, and then we'll have another sequence that starts at the summit and then goes down possibly the southwest rift some distance, right? If it's up here, it's probably okay. It's better if it's up there than if it goes all the way down in here. And that's what we don't want. Is it going down over here, right? But you can notice, for example, there is also an interesting other pattern here. Maybe I can zoom it in some more if it'll let me. And these are just patterns. Patterns will get broken at some point, but interesting to point them out, right? If you look down here, the oldest flow in the southwest rift is also the furthest south. The next time it goes a little bit more north, and then a little bit more north. Oh, it steps back a little bit more north, a little bit more north, a little bit more north, a little bit more north. The pattern has been moving north on the southwest rift zone as well. So you wouldn't expect something down here that would break the pattern. Not to say it can't happen, right? But it takes something massive like a magnitude 8 earthquake to open that flank enough to get it all the way down there. And that's essentially what reset Mauna Loa's south flank. Right, the last big adjustment of Mauna Loa's magnitude 8 earthquake. So since then, each eruption has come down slightly less far, and it's closed off a little bit more and comes in a little bit more. So the next eruption on Southwest Rift, if this was Vegas, you would probably want to bet up higher than lower as well, right? But that would still have to follow a summit sequence first. Right, and likely a summit-only eruption first, then a gap, and then a summit flank sequence. That's on averages, once again, right? Because the patterns are always going to be broken at some point in time. We're just looking at different buckets of time and trying to analyze it how we can, and that's what our brains do. That's basically
one interesting thing to me is about that summit flank sequence on Mauna Loa is just how much time can be between the summit eruption and then the system's primed and ready for that flank sequence, but there can be a significant amount of time between them, which is going to be, right now people are kind of on, we see Mauna Loa in the news a lot, and we're expecting it completely to erupt at the summit first. But after it does that, then it's really like, okay, now the game starts really in terms of people and populations, because now we can start seeing the signals. Hey, it's going to move towards the rift and more endangering populations. So that it's really interesting, that whole sequence there. I think this is go ahead.
Yeah, I also wanted to add that after the 75 eruption, there was a period of 1 week of seismic swarms, and magma was moving into the northeast rift, and for that first week they didn't know if it was going to erupt or not. In 1975, they thought it was going to go right then and there, and it went on. I want to say 2 or 3 weeks. Swarming, inflating, spreading. GPS was and then it backed off and stopped for 9 years. After that, and when it in 84 erupted from that exact same spot where the magma had come in 75.
Right.
So the 75 eruption normally the summit part of it tells you in advance where the flank one will go, because you'll see at the tail end of the summit sequence an adjustment of where is magma going now. Oh, it's going down to southwest. Okay, well that's probably where it's going to go. Oh, it's going down northeast rift. Well, maybe that's going to be the option now. So we'll learn a lot as time goes on and as we shift into higher gears.
Victoria has a question here, and I think this would be a good time to talk about it a little bit. With the classification of advisory on Mauna Loa, what does that mean, and what is the difference between green and orange?
I would have to look up exactly what their definitions are. I wouldn't know if I want to wing guessing what their definitions are exactly, right? But normally red's reserved for if it's erupting and affecting people. That's red, the way I think of it. Orange, like Kilauea now, is at orange. It's erupting, but it's not threatening people. so it's not red,
Right.
but it's erupting, so it's orange. Yellow, it's not erupting, but it's showing signs of unrest that it may erupt soon or it may not erupt soon. Wait and see what happens. We've gone to yellow and then back down before, and just to go back up again and back down again and back up again. So there's no guarantee that if you're at yellow, you'll get to orange or get to red. In the short term, anyways. Long term, it's a volcano. It's going to erupt sometime. You can't stop that.
Yep.
I did find this graph here from this paper that's showing this.
Go for it.
Months after initial summit eruption, right? So 0, this is kind of normalized, right? So you can see in 75, it went on 9 years to the next eruption on the flank, right? But before that, in 1940, it was essentially 24-month gap. 1933, 24-month gap. In 1896, 36-month gap. And 1880, I'm sorry, that was a 8-month gap. In 1855, no gap. In 1849, you had kind of a 2-year gap, but it was a false start, and really it was almost a 3-year gap right in there. So those are the examples of what you're talking about, just to put it in images for people to see.
Right. Yeah, that demonstrates it really well right there. Demonstrates it really well. I like this question. You might not be able to answer it fully, but I kind of like it where they're going with it. Kelly asks about the relationship that we've talked about before between Mauna Loa and Kilauea, but they're going one step further and saying, does the movement then affect Hualalai?
I don't believe so, gut feeling, but that's just like when we look at the signals on Hualalai, they seem to show the background of the island, like where the movement of the island without.
True.
You don't see as much of an effect over there on its GPS stations, right? That's one part of it, and that kind of leads to the fact of this whole northwest of the summit cluster is because Hualalai is not moving and it's not able to push it that well for some reason. And maybe if it was trapped on both sides, it would do that. But because the south side's free to go, it's just going to push. It's just going to go out and take the easy way out.
Go down that way, right? And one of the things I thought I've read this before. Correct me if I'm wrong. That there's some thought that Hualalai's magma chamber may not be similar to Kilauea and Mauna Loa, where it doesn't have that static body of magma beneath it. So I don't know, maybe that has some play in it too. I really don't know.
Right. It's essentially, you think of how we think of these volcanoes have shallow chambers and shallow systems and deep systems, right? We don't see anything shallow at all on Hawaii. So
right.
One way to think of it is, definitely is different. It could establish that sometime in the future, right? Kilauea at times has not had a shallow system either. It's reestablished, so that's kind of a mystery still.
More asks about the volcanoes that exist off the Big Island. That all I'm sure most of them are named, but are there any unnamed ones that are still out there, and are those being studied at all?
I don't know. We'd have to ask.
Okay.
Probably UNH Manoa Oceanography.
Right.
Ask.
Be good to find a map of like all the underwater features if they've been named or not. Have to try and look for that one of these days.
Yeah.
Good question though.
Oftentimes those names are, I don't know, it's like looking at the names of things on Mars, right? Or fairly meaningless, or named after something that if you don't know, if you're not in the know, it might sound totally random. There's probably a reason, but to untangle it is a whole other, the way oceanographers name things. So we'll have to leave to oceanographers to comment on.
We do have a $30 super chat from Gary Bryan, one of our frequent supporters. He says, really appreciate these updates and the work you both put into them. Thank you, Gary.
Mahalo, Gary. Yeah,
and we have a $20 super chat from Ryan Beelman. Just came through. No comment. Appreciate that one as well.
Ryan, yeah. We've covered a lot of different topics, yeah.
Yeah, I think that's about it for the questions today.
That's
And
mahalo,
yeah,
guys.
thank you, Phil. And I'll pass it to you.
Yeah, mahalo, Dane. Yeah, thanks for gathering all that and answering what you could in the chat. And that's our Mauna Loa update this week. We'll be back next week on Tuesday with Kilauea and catch you up on Kilauea. And once again, a week from today, and next week Friday, I'll come back to Mauna Loa, and I would expect to see another swarm between now and then, perhaps, or unless something major happens. If we see like a big flank earthquake, I'm not sure it's coming that soon. You can't just tell by looking at the map, right? But we'll keep our eyes open, and see it. Unless something else happens, we'll obviously jump back in and special coverage of that. But in the meantime, until then, for Hawaii Tracker, Dane DuPont, Labong, aloha everyone.